So this example of an infinite series is where a ball is dropping and then each time that it rebounds, it bounces to 40% of its fall. So if you've ever watched a super ball, right, one of those little hard bouncy balls, right, it does this little da-da-da-da-da at the end, right? You kind of imagine that, right? So we're pretending like it's going to go on forever. So I'm going to draw just a quick little picture here so we can get an idea of it. So wait, we start from 21 feet up. We're going to drop the ball, right? So it's going to do that first 21 feet. It's going to bounce up and then come right back down. Right? And the height that it's going to go up is, right, 40% of how far it just fell. Right? So 40% of 21. But it's going to go up and it's going to go back down, right? So we're looking at the total distance that it travels. So we're going to get two of those. Okay. Now the next time that it bounces up and comes back down, it's going to be 40% of that amount that it just did. So that'll be 0.4 times, right, that last height that it dropped, which is 0.4 times 21. Okay. But again, it's going to go up and come back down. So another times 2, right? So 0.4, 40% of 21 is this drop down here, but I get one for going up and one for coming back down. Same thing here. I get 40% of this fall, but then I get another one of them because it goes up and it comes back down. Okay? So if we're going to make a series here, and I'll start just by writing out the terms of how far it has fallen, or how far it has traveled. So right, 21, I think that's going to be its own thing at the end here. So 21 plus, then I have 0.4 times, I've got that 21 times 2 in each of them. I'm just going to do that and write a 42. Okay, so in this next one, right, so there's our initial drop, here's our first bounce. Comes our second bounce. So I'm going to have 0.4 times 0.4, or 0.4 squared, times 42. Okay. Can you imagine what the next term would be? Right? Plus 0.4 cubed times 42. Right? It goes on forever. So plus on out to, right, infinity. So can we write a formula for what's going on? Can we write a summation notation for this? Okay. Well, 21 plus, so 21 is going to be its own thing, right? And then I have 0.4 to the n times 42 if we let n start at 1 and go to infinity. That will get us all of the terms here in the series that I have, right? So I've got the plus 21 just to go along with it. Well, this is a geometric series. Right? Each successive term goes up by the same ratio, and that ratio is 0.4 less than 1, so my series converges. Having a hard time with my camera today, sorry. Okay, not only does it converge, but we can find the sum, right? So the sum of a geometric series, right, is your first term. Just do a and then divided by 1 minus r. So for us, our first term is, careful, because the 21 is its own thing. I'm just going to add the 21 here at the end. So the first term in our series here is 0.4 times 42. And then our common ratio, r, is 0.4, so 1 minus 0.4. So if I put that into my calculator, what do I get? 0.4 times 42 divided by 0.6, 28. Right, so 28, what did we have? Feet in the bouncing. And then I have the original fall of 21. So it looks like 49 feet would be the total distance that the ball travels.